everyone. Thanks for joining us. This is James from the Control Listen podcast brought to you by Octopod. Today we have a special guest, Sasan Hashemi, the co-founder and CEO of Tset. Thank you so much for coming on the show. It's great to have you.
Hey, James. Thank you for the invitation. Thank you for having me.
Anytime. Do you want to maybe start by telling us a little bit about Tset's story, what the company does, and your background in the industry?
Oh, yeah, sure. So we at TSET, we focus on product cost management. We provide here a software as a service platform focused on very clean data management, centralized data management, using the newest technology in terms of automation, be it 3D algorithms or AI. We were founded roughly, now it's been 8 years ago. Myself, my background is I'm a mathematician actually. I did
Oh, okay.
software-driven algorithms and software for first the banking and insurance industry, and then I switched into manufacturing. My co-founder, he is a cost engineer himself for over 20 years, and yeah, we looked at the sphere of product cost management. We saw that there's a very high need in those terms.
Okay.
Be it market external factors or just having clean data to be able to run analysis and realization on. Yeah, and we came to the conclusion that it's really makes sense to build a new platform. So we started a journey. We focus on enterprise customers from different kind of industry, aerospace, defense, automotive, machine manufacturing, off-highway vehicles like tractors and agriculture machinery and things like that.
Okay.
And yeah, so we're doing this out of Vienna. We're a European company with a global footprint. This is what we do.
Fantastic. Awesome. Um, First question, is there a lot of difference between all these sectors? So obviously, you work in a wide space. Do you find a lot of similarities between all of these varied sectors?
Yes and no. So at the end of the day, it's about making your products more profitable and sustainable on a short and long term. There's a lot of different aspects that are emphasized in different ways depending on the industry. So you have
Mm,
kind of the purchasing aspect. When you buy a lot of manufactured parts and components, you need to have a good hang on the cost and carbon footprint of that.
hmm.
But you have the perspective from sales side too, of course. If you're in the supply chain, tier one, tier two, you need to make yourself a business case and be able to argue that and sell that. And of
Hmm.
course, from an R&D engineering perspective, you want to take the right decisions that then will end up you having a good, functional, but profitable and sustainable product. So there's different angles in terms of department, and depending on what kind of industry you are, there's maybe an emphasis more on this or more on that. For example, in automotive, it's very, very strong emphasis on the purchasing side. In R&D,
Mm,
there's a very strong emphasis on the R&D side. It
hmm.
depends on the life cycles of the product too, but at the end of the day, the goal remains the same. And to be frank, kind of the manufacturing technologies used are the same. I mean, of course, there's
Okay.
different functional requirements, but at the end of the day, like a casting part or a PCBA is a PCBA. It doesn't matter too much if it's in a washing machine or in a car. Maybe
Right.
the requirements are a bit different, but at the end of the day, the base physics and manufacturing technologies and the manufacturing model behind it is rather similar.
Okay.
Of course, there's another difference in terms of production volumes,
Mm,
right? I mean, if you make cars, maybe you have different product. You will have a different production volume than making planes, and
right.
that again reflects into manufacturing technologies. But at the end of the day, it's again a manufacturing model of the
Hmm.
component, and yeah, we of course we have to adjust things for some industries, but the core of the activity and the requirements stays the same.
That makes total sense. Thank you. So I want to bring it back to more of a base level for anyone who maybe isn't as familiar with some of the stuff that you do. So can we start by maybe having you explain what carbon reduction is and how companies benefit from something like that?
Oh, sure. So the idea of carbon emission reduction is basically really was born now it's born for a long time, but it got really a drive through the global climate goals
Mm,
and different mechanisms, being on a global level or maybe on a European level, US level, how to reduce carbon emissions. That is relevant on its own on a geopolitical level. It is relevant from a sustainability point of view, what is the right thing to do. And
Mhm.
given different types of tariffs, taxes, penalty instruments, especially in Europe, the European Union is having a strong focus on that. It becomes actually very relevant for the profitability of your product. So it's really a difference if you have 10 tons of CO2 emissions and CO2 like emissions. So normally you say in the industry CO2 equivalent. So methane is something maybe that is not CO2 directly, but it has a
Mm.
similar effect. Measuring that and building products and having a supply chain that is efficient in terms of energy consumption and in terms of the type of energy that is consumed is very important, not only from a sustainability point of view, but straight out in your P&L.
Mhm.
So that's really where we came from because we started with product cost management, but for us it was very important. We want to have the total cost of ownership of the product. And if regulations and mechanisms basically translate carbon emissions
Mhm.
into costs, euros and dollars, then this has to be part of a product cost management. So we normally do not internally distinguish between euros and dollars and CO2, but we talk about the
Right.
true cost. And that's just the additional factor that will play in going into the future. It has
Mhm.
slowed down a bit given this geopolitical situation overall and the economic situation overall. But
Mhm.
given that the underlying driver of global warming will not go away that soon,
Yeah.
we see that it will come up again and it will, in some parts, maybe have a drastic effect on supply chains and productivity.
Right. Yeah. Something to think about, even though some people don't want to think about it. So, what does cost and carbon calculation entail? How does this whole process work, and what are the key points would you say in this process?
Sure. I mean, at the end, how you can imagine it is that you build up a manufacturing model. You know, like
Mm.
you look at the, let's say, at the car, very good example. And you say that car has a chassis and it has windows and it has like an engine, a battery, and you split it up by these components. That's like kind of the bill of material. And then, of course, the powertrain has again subcomponents, and so on. And that is a typical engineering bill of material.
Mm.
When you look at modeling the cost and having really all the drivers, you're looking more in terms of a manufacturing model. So, like, not only what is the subpart, but what are the materials and the processes and the consumables that go into it. And you can model that, right? You can
Mm.
say, oh, this is this casting part, or this is the sheet metal part, and I have to first cut it, and then I have to bend it, and then I have to clean it, and maybe I have to do some galvanizing. So these are work centers, and for the galvanizing, I need material, and for the painting, I need material, and that material comes from a place. So you basically model the supply chain.
Right. Okay.
And this is what our platform allows you to do. You can model the supply chain, and we have some pretty cool algorithms that if you give it, for example, some parameters about your product or a 3D model of your parts, then it will do that modeling for you. And
Okay.
based on that, what you get is like a very detailed model of the supply chain of your part. And now you combine it with assumptions. You say, oh, that machine is probably costing 2 million, or that machine has a energy consumption of that kilowatt hours, right? And then you
Hmm.
say, okay, that machine is in Shanghai, and in Shanghai, the energy mix is that much CO2 emissions, and it costs that many euros per kilowatt hour. And now all of a sudden, you have kind of the variable cost of a machine calculated. And you do that for a lot of parts. So this is where our data management is very important, and that we need to be
Mm.
very performant and secure. But based on that, you have like I always tell people is like imagine it as like really really big Excel.
Okay.
And funny enough, this is what most companies do. So we did not invent product cost management or modeling these costs.
Right.
But we saw that companies really struggle getting on top of this with a lot of Excels, and in an age where you need structured data to make the most use of analytics and technologies like AI, we had a pretty good timing in the last years, and we're able to help a lot of clients.
That's fantastic. Um, so to put it simply, if people are asking how is carbon reduction measured or tracked, how would you kind of explain that final part of the process where you actually present to the client, this is how you're saving?
Yeah. So when you think about the carbon emissions overall, you have to think in like different scopes. So normally there's like kind of three scopes. There's scope 1 and 2. That is like if I'm a car maker, what happens in my plants?
Mm,
What happens, like if my employees fly with a plane? That's like kind of my scope 1 and 2. But normally in the manufacturing industry, the biggest part, especially for EMs, of your carbon footprint is either of the usage, scope 3
mm,
downstream, you call it scope 3 downstream, or from all the things that you buy in order to assemble your product. And that is the scope 3 upstream. And we are focusing on that scope 3 upstream. So we say, in order for you to build a plane or a washing machine or a phone or um, a car,
mm.
this is the components that you buy, and then based on the modeling of the manufacturing of these components, this is the amount of energy basically and gases going into that, and based on these assumptions, this is the carbon emission that is emitted during that production. And that is
Okay.
something then you can take, look from a sustainability point of view on it, and look from a commercial point of view for on it. For example, in Europe there's something like the carbon border adjustment mechanism. So
Okay.
when you want to import components and parts that are out of steel, that is the first step, and they will extend it. Then the European Union will ask you, well, that's what's the carbon emission of that? Where do you this import this from? And
Right.
if you don't pay taxes on that in that country, then you will need to pay taxes on the import. So it's a very real tariff that has
Okay.
to be calculated in your purchase price.
Interesting.
No,
So I
sorry,
saw you.
I have the feeling it was too complicated.
No,
No,
I think that's fantastic. Thank you. It makes
yeah.
total sense. So I did see on your website though that you had listed 5 steps that companies can take to reduce costs and carbon. Do you want to maybe run us through what those were?
Yeah, sure. Of course, it always really depends on how you where you are as a company, right?
Okay. Okay.
But to make it maybe even more simple, what you want to do is, if you really want to do it simple, it's always like two components. You need to first map a baseline. You need to analyze your parts.
Hmm.
In a lot of companies, that is might be shocking to some of our listeners. Companies just don't know really. Like if you because you have the accounting that is like on a plant level, right? On a corporate level. But if you say go somewhere and say this exact product, how much does this cost? People struggle to answer that. So the first part is really mapping the is status, and for that, that means basically mashing a lot of data, like purchasing data, your internal plant data, and so on, so that you have a baseline. What you then do is you go and you do a heat map analysis, very high level, and you say, where is this coming from, right? And normally
Hmm.
there's like kind of Pareto principle: 80% of the cost come from 20% of the components or activities that are the driver. And then you start building for those drivers models, and you do an analysis of, in an ideal world, how much should this cost and what is the gap. Here you have to really distinguish about the product life cycle. There's something like should cost. So you have a part, and that part is being produced, and what should this particular part cost? That's called should cost. But there's also something like could cost, where you think in an earlier stage when you're in conception or in design of the product, you say, okay, how could I change this product to have a lower footprint in terms of cost and carbon emissions? So these
Okay.
are kind of both worlds. Of course, the could cost, you have way higher leverage, right? You can change more, but the return is longer, and of course, you have more restrictions.
Hmm.
On the should cost side, yes, you get a faster return, but you have a limited amount of possibilities, because, as you know, it's sometimes not that hard or easy if you already sourced a part and you're working with a
Hmm.
supplier. to tell them, hey, could you please, like just change the part, and
Yeah.
that could get very complex. So these are the kind of
Yes.
technical and commercial world. And yeah, and once you do that, you go into realization and tracking, right? So you have your
Hmm.
ideas, analyze where are the drivers, what is the potential long term and short term, and then
Sure.
you work with the different expert departments, be it purchasing or design engineering or sales, to actually realize it. I mean, there's a famous saying of my co-founders, like numbers are cool and modeling is super nice, but at the end of the day, it's just air if it's not getting realized, right? So
Yep.
you have to somehow, in German, we say you have to get the horsepower on the ground, right? You need to get this mechanism, and their collaboration is absolute key, and awareness for the topic in the different departments is key to be not just analytical but actually effective.
Okay. Well, thank you. That makes sense. Um, I like the fact that you also just didn't break it down into five simple steps. You made the whole process make total sense. So thank you. So you kind of answered a little bit of this already, but I just wanted to go back over it. Why would you say it's beneficial to begin, considering CO2 and cost optimization as early as possible in the design phase? Obviously, it gives you more time to work with things, but are there any other benefits to work factoring this in early on in the process of product design?
Yes, because you have higher levers. It's at the end of the day, it's relying on itself. So I think first, if you do cost, you should do CO2 anyway because they will be tied together going forward. And the second point is you should always in engineering be doing very conscious decisions.
Yes.
And that means taking into aspect not only functionality or supply chain risk, but the cost footprint and the CO2 footprint. And having that in a very early stage is just a very strong feedback mechanism to the engineers to very early on, again, not reduce costs or carbon reduction because they don't exist yet. It's all on paper, but avoid them altogether.
Okay. Again, it makes sense. Thank you. So I was wondering, would you be able to maybe walk us through a couple of case studies that you worked on, just to give us some context to kind of make it more grounded, more in reality for everyone?
Oh yeah, sure. I mean, we have, for example, one customer. They did the activity of should costing and procurement on a very rudimental level. We worked with them from a software side and from a business side to go through their spends. Within the first year, they saved more than 17%.
Wow.
Yeah, which was triple multi-million level.
Wow.
Then we had another customer in the machine building industry where we worked very strongly with the engineering team to because they what they wanted to do is a modular platform, which is very important in terms of variant management. But we put additionally to the manufacturability and the modularity in terms of product function. We took the cost function into account, and we had actually really good results in terms of driving key decisions that they are not only functionally modular, but their cost is modular in the same way and doesn't over complexify the supply chain and the cost associated to that. And another example was we were working with a tier two supplier where we were able over 24 months, 2 years, to increase their close rates on RFQs by 25%
Wow.
because they were able to do more competitive pricings and they were able to argue better their pricing, which led to higher trust with the buyer and yeah, to at the end closing more.
Thank you. See, this is why it's important to have these, because I think people might look at something like this and say, "Oh, what would I be saving?" Like a
Yeah.
million dollars or something. But when you actually see it in context, it's substantial amounts of money that people could be saving
Oh,
by using a
absolutely.
service like this.
And it's sometimes very simple. I mean, you just think about it. You have a sheet metal part that you buy. You don't think too much about it. You buy a million pieces maybe a year because that goes like really in multiple places in your old kind of products that you're producing, and that one part costs you 20 euros, and now you come and you save €1 on it. So you just saved the company 10 million You're,
Yeah,
yeah.
yeah,
So,
that's the
so
bulk side of things.
yeah, yeah. So the impact is really, really high, and it's a bit about ideology too, I would say, or approach. So of course, when you be it on the sales side, on the development side, you can always argue, of course, like to tendency, you don't have to have a very detailed model. But when you have these models that you can easily interact with and access the data very easily, then you can quantify, right,
Hmm.
directly what is your argument and where is the difference. And sometimes, it's about, okay, it is more costly, but that's worth it because we know exactly how much more it costs for that function, right? If you don't have that, a lot of times you're like, I think it's more expensive, but I think it's worth it, and you do not have concrete numbers. And given that now, especially nowadays, we really in the manufacturing industry in a lot of places we have structural cost problems, and there's a lot of maybe some places cutting costs.
Yeah,
It's really important to talk about concrete numbers and be data driven in your decision making.
yeah, yeah, for sure. So just to change topics very slightly, I noticed on your website that you have a collection of webinars and resources. If people are going to check those out, are there any particular ones that you think would be most beneficial for people to read or watch?
I think it's a good mix. So we have one on the CO2 topic, like a white paper. We have one on the ROI. We have multiple webinars with clients. I think our goal was to be very wide because like we have a very wide type of clients. I think the one with Akko, again, depending on who you're talking to. These guys, the client of ours, but they do a great job of connecting their systems and having
Okay.
basically giving the relevant data to the decision maker at the right time. And that is really enjoyable how they think about it, how they think about the
Mm,
system landscape. So that is definitely one I would yeah recommend. But again, there is one with Chiron, which they have very different type of challenges.
okay.
Again, depending on who you are, I would just recommend just scroll through them. I think we have always like a bit of an abstract. See if you can, yeah, sympathize with the situation. You see yourself in
Hmm.
it, or you see it practical, and just go for
Sure. So I wanted to take a step back from looking, specifically at your company and look at some of the trends in your sector.
it. Mhm.
So I want to start by discussing what would you say are some of the carbon reduction trends that you've noticed in recent years? How have things changed in the last couple of years in that space?
Well, I think step number one is to get a baseline, and that is
Mm,
sometimes very difficult because there's like companies that have hundreds of thousands of parts. So they started, a lot of companies started with simpler methods. But one of the methods about analyzing the carbon footprint is they called it the spend-based method. So you basically say, I have a factor which I multiply on my cost,
mm-hmm.
and that will be roughly my CO2 output. And it's not wrong because normally things that cost more have more weight, more CO2. Um, but it is absolutely misleading in some places too. You can imagine. I don't know. Like I buy a graphic card, right? It's very expensive, but it doesn't mean that it has the same carbon footprint like maybe a custom part that is too cheap. So that is something that you should look out for.
Okay.
And over time, they try to get more and more sophisticated.
Mm,
And and I think now we're at the point that they're combining this carbon analysis with the costing
mm-hmm.
because on the costing side they already have a lot of analysis and they try to out of that derive the drivers, so to say,
Okay.
of what is the weight, what type of material is it, where is the material being sourced. Some first companies that I saw, they were smart. They tried to secure the global supply of green steel because they
Mm,
and strategically, okay, green steel production will have a limited amount. So, and that is again a price delta. So this is how most companies started, but it actually always starts at the OEMs, right? So the OEMs start. either strategically because they already want to plan with it, or driven by legal instruments. I would say these legal instruments are roughly defined, but they are not really hurting yet. So
Okay.
it's not like someone is that is problem, but it is very clear that it's just a matter of time. So the big OEMs are already there, and once you have the OEMs, they will push this through their supply chain,
Okay.
right?
Okay.
And then they come into situations when an OEM asks its purchaser, "Hey, please, for all of your spend, all of the parts that you're buying, tell me what is the CO2 footprint."
Mm.
And they go then to the supplier, and the supplier is like, "How should I know this? I don't have a methodology." And then they
Yeah.
call us and say, we need this super fast. And what we do normally is we give them a fast analysis of what they need, but then we give them the tools and the knowledge to be able to include this in their daily operational work. So for future requests, they can do it. But it's kind of a trickle event through the manufacturing pyramid top down.
Okay. Interesting. Thank you. I think it's really important to understand like a big picture view of the space to really understand how your company operates within it.
Mm.
And something you talked about is the evolving intelligence in this space. I want to discuss what do you see as the role of AI in carbon reduction, and how do you see this evolving in the coming years?
Yeah. I mean, AI is a very big word.
Yeah,
Uh,
yeah,
but I would interpret it as like kind of the newest AI advancements, which are more in direction of text models, LLM models,
yes,
large language
yes,
models.
hmm
So I would say it's going to be very impactful. Just maybe not the way that people think about it. So um, these models, I mean, you can use it for calculating stuff. I mean, everybody can go on ChatGPT and give him like some deep calculation and it will answer, but this is not really what they were built for.
yeah,
They're extremely good. What they're extremely good at is categorizing things, like understanding things and categorizing things.
okay,
And that is a very big task. So because you're at the end of the day, every modeling of cost in CO2 is a parametric model. It has inputs and outputs. And
yes,
having all the set of the right inputs is the work that you need to do, all the right assumptions. And I think AI will help very strongly to take the existing data that is sometimes scattered and not very structured, product data, commercial data,
hmm
and transform it into structured input, which then cost models can work with. I think that is definitely something that will happen.
okay,
Um, or I mean, definitely strong feeling. Um, and then I think so that's on the input side. And I think then on the output side, there will be some development too, because you have a cost model, you model your complete product, and now you get a lot of numbers, right? You get one result, but you don't only get one result, you get thousands of results, right?
yeah,
For every part, you know all the cost parameters. And that can be overwhelming. And that is just one product, right? And let's say you have
yeah,
thousands of
yeah,
products. Now all of a sudden you have millions of numbers. So you have to understand, you have to cut through the noise of these numbers, and maybe even without the knowledge, deep knowledge of the models itself. And that will be kind of an explanatory use case where, like, imagine, like you go to an expert and you sit down and say, okay, I see a gap of 30%, but can you explain me where is the driver? And,
yeah,
and I think that kind of translation of number into language and into measure, basically, like
yeah,
what's, because at the end of the day, the output is a measure. What should I change? What is the action? The translation of data into action, or data into insight, however you want to
yeah,
call
hmm
it. That is something that I think AIs can help. I wouldn't say now just general AIs. I wouldn't recommend to just throw something into ChatGPT. Uh,
yeah,
but of course, these large language models can be trained vertically, or
yeah,
let's Fachjargon, like vertical training of general models for specific use cases. And I think with enough training and use cases, this will be good. Of course, the drawback is always that these LLM models are based on chance. So
yeah,
sometimes they're not consistent. I think it's a solvable problem. So you just have to work with it, and you have to build in really good quality assurance. But I think it will take some time. First, that the technology is there and the use cases are, so to say, mature. And second, that the trust is there. Because
Sure.
at the end of the day, if you're an advisor, you model and you create action points, what you build on is trust, right? So
Hmm.
you can have one really bad advice and 100 really good advices don't count because that one really bad advice was very off.
Yeah. Yeah.
So that is very important that I don't see like some AI agents running around and optimizing from their own, but I think these things can help experts to be more productive. So I see it more
Yes.
into a co-pilot term point of view.
Yes. Yeah, we had a guest on the show a few guests ago, I think it was. We had a discussion about AI and how you need a human factor to balance things out because one wrong part of the algorithm will just keep building out incorrect data from there, and we'll learn from the incorrect data and just spiral out basically. So you need the human factor to check things to make sure that it is working things out correctly for sure.
And of course, it's about the magnitude of errors. I mean, back to your example, if you sit down, you model, and you save €1, you save 10 million. But on the other side, if you miss a euro, you just lost 10 million, right? So, so,
Yeah,
so it really is important. What is the cost of error?
yeah,
And especially when you look at cost modeling, cost management, the cost of error, depending on what stage you are at, right, can be huge.
yeah, for sure. What would you say that the effects of global events such as COVID, regional conflicts, and tariffs have had on the carbon reduction space?
I think it slowed it definitely out. I don't think that it's like people are like, oh, it never happened. No, but it definitely slowed it down. There is just, especially in Europe, the manufacturing industry is under enormous stress, and tariffs make things harder. They make supply chains harder. They drive costs up, and when you're fighting for survival, then of course sustainability is a bit difficult to have as the number one priority. So that definitely was a factor, and it is reflected really in the regulations because they come out slower,
Yes,
right? But as the optimist that I am, I think that the geopolitical and other factors like COVID and so on, I think we will smooth out of here. Um, and I'm a big believer in carbon emission analysis. At least like that like I'm not here to preach anyone, hey, you should reduce your carbon reductions. That's my
yes,
personal opinion, is doesn't matter, but I say you should at least know what they are, like, and
yes,
then you can consciously decide that you don't care, but you should know what they are. And I think that's a long term trend that will stay. It has now a hiccup and is slowed down a bit.
mm,
But I think in general, given that I mean we're talking about AI, if you just calculate the forecast of how many data centers there has to be to match
yeah,
the demand of AI in
yeah,
the next 10 years, and if you calculate that the really big data center almost needs a whole nuclear reactor to supply it with energy, then you see that we need to be smart when it comes to carbon reduction because otherwise
yes,
it just, the numbers doesn't work.
yeah, for sure. Yeah, thank you. And I'm glad you see it with such a logical viewpoint. Last question, easy one. If people want to follow your company or get in touch, see what your offerings are, what are the best places to do that?
We have a great marketing team that is doing, I think, a lot of good work on LinkedIn. So just
Okay,
follow us on LinkedIn. We have a newsletter where we give you infos about the upcoming events. We have an event now in Munich called the Future of Cost Engineering in
okay,
November. Happy to join there. Limited amount of space, so you got to be fast. And given that, I mean, we're not really a startup anymore, but we are a young company. We're like roughly 60 people. We're pretty simple. You can just drop us a line and we will answer. It's not that
Fantastic.
it just yeah,
I can confirm this because I've done so myself to in contact with you. So, yes.
fantastic.
Well, thank you so much for coming on the show. It's been fascinating talking to you. I think I myself definitely have a deeper understanding of carbon reduction and how the process works. Appreciate your time.
Thank you, James. Thank you for inviting me.
Anytime. And for anyone tuning in, thank you so much for listening and come back next time for another guest.